We are from Bachelor of Elementary Education, Black Sea. By the way, I'm Laika Almoreggi, and this is my group mates, Stephanie Bartolay, Sheila May Camposano, Cherina Litada, Jason Paul Abraham, and Ronnie Vincent Sola. Are you ready to explore the three states of matter with us? I'm sure you are familiar with the three states of matter: solid, liquid, and gas. When we look at something, our brain automatically knows it is a solid, liquid, or a gas. In this video, we are going to compare these three states of matter in a more scientific way. So we will compare them based on these four properties: the shape and volume, compressibility, rigid or fluid, and though they fill their container completely after that, we will take a deeper look into solids, liquids, and gases, and compare them at particle level. Let's start with solids. Solids have a fixed shape. Yes, as you can see here, they have a fixed shape. This is a cuboid, this is a cube, this is a sphere, and my watch has a regular shape. So for solids, the shape does not change. Now, do solids have fixed volume? Again, the answer is yes, because the space that the solids occupy does not change. The volume is fixed, and we can calculate that volume, for example, of a cuboid is length into breadth into height. The volume of a cube is a cube. The volume of a sphere is 4 by 3 pi r cubed. Now, how do you calculate the volume of watch which has a irregular shape? That's right, Archimedes' liquid displacement technique. If I dip this watch in water, then the volume of the watch is the volume of the water it displaces. I actually have a video on Archimedes' liquid displacement technique, so do check it out. Now, let me pull out my watch before it stops working. Let's look at the compressibility of solids. Usually, solids are difficult to compress. For example, I can't compress the things on the table here. So if I try to take this cube and I try to press it, I can't compress this cube. Here, there are some exceptions, like a sponge. We'll talk about that toward the end of the video. Are solids rigid or fluid? That's right. The correct answer is rigid, because they have a fixed shape. Fluids are things that can flow. Now, do solids fill their container completely? For example, if I try to put this ball in this container, here, does it fill the container completely? The answer is no. Let's add the properties of solids to our concept board. Now, let's take a look at liquids. Liquids have a fixed volume but no fixed shape. I'm going to prove these 2 points to you with one single experiment. Here, for the experiment, I have taken water in this beaker, and as you can see, there is 100 ml of water. Here now, I'm going to transfer this water into this container. This one, and you carefully take a look. What is the change in volume and shape of the liquid? So are you ready? Let's start now. I'm going to transfer the water from this beaker into this bottle. And then I will transfer it to the glass. Now, let's transfer it to the measuring cylinder. So what is the final volume? Here, as you can see, it's 100 ml, and that's exactly the original volume. So what is the conclusion from our experiment? Liquids have a fixed volume. It was 100 ml all the way through, but they don't have a fixed shape. As you saw in the experiment, the liquid takes the shape of the container it is put in. Let's talk about the compressibility of liquids. If you take a plastic bottle like this containing water, if I try to crush this bottle, it looks like I can compress the water. So are liquids compressible? The answer is no. When I'm crushing it, I am really compressing the water? No, I am compressing the air inside the bottle. Now, if we fill this bottle completely with water, I need to be Superman to be able to crush this bottle. So liquids are almost incompressible, just like solids. Are liquids rigid or fluid? That's right. The correct answer is fluid. The word fluid means it can flow easily. As you can see, water can flow easily, so liquids are fluid.
Now, let's take a look at the third state of matter, gases. Gases have neither a fixed sheet nor a fixed volume, just like liquids. Gases take the shape of the container that they are in. One difference is the container needs to be closed. Now, liquids have a fixed volume, but gases don't even have a fixed volume. The volume of the gas is the volume of the container. So, for example, if I transfer this gas into a larger container, it will fill the container completely. Or if we apply some pressure and try to fit it into a smaller container, then the volume of the gas will be the volume of the smaller container. That brings us to the next point. Compressibility gases are highly compressible. For example, I can easily squeeze this balloon, or I can easily crush the air in this bottle. Gases are usually stored under high pressure since they are highly compressible, that we can't fit more of the gas in a small container. For example, compressed natural gas is stored in cylinders at a high pressure just like liquids. Gases are also fluids. They can flow. For example, if I open this bottle, can you see the air flowing out? Of course, you can, because air is colorless. But let's say it was a colored gas, then you would easily see it flowing out of the bottle. In fact, the term fluid is collectively used for liquids and gases. As we discussed before, gases are greedy. They want to fill up the container completely. For example, if this bottle contained a gas and I transferred it into a larger container, then the gas would fill up the larger container completely. Another example is when you open a perfume bottle in a room, the smell spreads the entire room. So here, the room is like a container. So the perfume gases fill the container completely. Now, let's spin the properties of gases to our concept board. We have discussed the difference in properties between solids, liquids, and
Liquid or gas is made up of tiny particles. For example, ice water and water vapor are all made up of the same tiny particles, that is the water molecules. Now, let's compare the three states of matter. At the particle level, based on these 3 points, the distance between the particles, the force of attraction between the particles, and the amount of movement or the kinetic energy of the particles. To get a visual feel of things, I would like you to hold up your hands like this and imagine the tips of your fingers as particles. So are you ready? So this is what a solid would look like. The particles are tightly packed. The distance between the particles is very small. The force of attraction between the particles is very strong. So you have to apply a huge force if you want to change the shape of the solid. Even in a solid, the particles are moving, vibrating about their main positions, but their movement is less kinetic energy of the particles. Small. Now this is what a liquid would look like. The particles are more closely packed. The distance between the particles is bigger. The force of attraction. I hope the three states of matter are crystal clear to you now. So, remember, this is a solid, this is a liquid, and this is a gas. Thanks for watching and listening.